Hello everyone, and welcome to KubeCon and Cloud Native Con London. My name is Gamanji, and I am a senior engineer at Apple. I'm also part of the TOC, or Technical Oversight Committee, within CNCF. Last year at WWDC, we introduced Apple Intelligence, a personalized intelligence system that brings powerful generative models to iPhone, iPad, and Mac. Apple Intelligence is designed to protect your privacy at every step. To deliver this advanced security architecture, whenever possible, Apple Intelligence processes tasks locally on the device, but more sophisticated tasks require additional processing power. Private Cloud Compute, or PCC, allows us to scale our computational capacity and draw on even larger server-based models for these complex requests. These models run on servers we have especially created using Apple Silicon and offer the privacy and security of your iPhone from the Silicon On app. Private Cloud Compute is a great example of how we're investing in and adopting open source technologies. We draw from the security properties of the Swift programming language to run software with transparency built in and leverage the high performance and resilience of gRPC for the transportation layer. gRPC is a mature CNCF project with more than 8 years of upstream development. It is a widely known framework that can efficiently connect services across distributed infrastructure. And within private cloud compute, we heavily leverage the building blocks of gRPC for the transportation layer. Bidirectional streaming is a core part of gRPC that we use to communicate load information between the PCC gateway and a single Apple Silicon server. Since privacy and security is at the root of our components, we ensure the response payloads are encrypted by the user device and routed using gRPC to the PCC gateway all the way to Apple Silicon machines. And finally, gRPC has a very robust liveness probing that is highly configurable. As gRPC controls its underlying transport, we lean into its resilience to ensure it is capable of performing these probes. From a technical standpoint, some of the libraries we use are gRPC Swift and Swift Protobuf, which in simple terms are the Swift implementation for gRPC and Protobuf. And at Apple, we've written all kinds of services in Swift, from iCloud Keychain to App Store processing pipelines and SharePlay file sharing. And when building out a service that supports Apple commitments to user privacy, Swift was a natural choice for several reasons. From a performance standpoint, Swift has a very low memory footprint that keeps the system resource usage down. This enables us to make the most efficient use of our hardware for inference within PCC. We're also able to leverage our existing investment in memory-safe protocol implementations. By using Swift libraries throughout the stack, we minimize the amount of unsafe code parsing untrusted data, shrinking our attack surface. The same policy was applied throughout the entire code base. And finally, we spent a number of years collaborating with the community to build an open-source Swift server ecosystem that has great solutions for privacy-oriented services. Private cloud compute is a great example of how we're bringing together two open-source ecosystems and a decade of innovation. High resilience and performance of gRPC with the security properties of Swift enables us to bring industry-leading device security models into the cloud. We're looking forward to continue our investment in these communities and make Swift a platform for the cloud and server development. If you'd like to learn more about our use cases in the cloud-native space and how we engage with the wider ecosystem, you can attend one of the 10 talks delivered by Apple engineers at this conference. And to explore how Swift can be a fast, modern, and safe language for your server, you can check swift.org/server for more details. And if you'd like to learn more about private cloud compute, you can go to security.apple.com. This is Gamanji, and I look forward to seeing how you can shape the open source ecosystem. Thank you, and enjoy the rest of the conference.